For years, multinational corporations looked at this site and walked away. The challenges seemed insurmountable, the risks too great, and the costs, well, they were just too unpredictable. Mining experts even called it the Hell Mine, a place where equipment froze solid, workers collapsed from oxygen deprivation, and landslides could wipe out months of progress in minutes. So, when China announced in 2014 that it would purchase this notorious project for $7 billion, the global mining industry reacted with disbelief. Critics called it reckless, skeptics predicted failure, and financial analysts questioned the wisdom of pouring billions into what many considered an impossible venture. But, a decade has passed since that controversial decision, and today the story looks remarkably different. The copper mine that was once dismissed as unworkable now operates with cutting-edge efficiency. The investment that was mocked as foolish has generated returns that exceed $27 billion. And the country that took the risk now controls a strategic resource that powers the global transition to clean energy. So what really happened in those 10 years? How did Chinese engineers overcome obstacles that defeated some of the world's largest mining companies? And what does this transformation reveal about the future of global resource competition? If you're interested in stories about economics, geopolitics, and technological innovation, make sure to subscribe to our channel. You'll get access to all our latest documentaries exploring how major powers are reshaping the world economy. Now, let's dive into one of the most remarkable engineering achievements of the 21st century. The Las Bambas copper mine sits more than 4,000 meters above sea level in the Peruvian Andes. To put that in perspective, that's higher than most ski resorts in the Alps. At this elevation, the human body struggles to function normally. The air contains only 60% of the oxygen available at sea level, making every physical task exhausting. Workers arriving at the site often experience severe altitude sickness within hours. Headaches pound relentlessly, breathing becomes labored even when sitting still, and nausea and dizziness are constant companions. For many people, it takes weeks to acclimate, and even then, productivity remains significantly reduced compared to operations at lower elevations. But the thin air is only the beginning of the challenges. The temperature regularly plunges to -10 degrees Celsius, cold enough to freeze hydraulic fluid and crack metal components. Snowstorms hammer the region more than 200 days per year, sometimes lasting for weeks without interruption. During these storms, visibility drops to near zero, and mining operations must halt completely. In the early exploration phase, one international team had to abandon their entire camp when a 2-week blizzard made resupply impossible. They left behind millions of dollars worth of equipment, unable to safely extract it from the mountain. Transportation presents another enormous obstacle. The mine is accessible only via a single dirt road that winds precariously through the mountains. This road is narrow, unpaved, and frequently blocked by rock slides. Ice forms in cracks and crevasses, making sections impassable for weeks at a time. Heavy mining equipment cannot be driven to the site in one piece. Instead, massive machines must be completely disassembled, transported as individual components, and then reassembled on site. This process multiplies costs by a factor of 3 compared to typical mining operations. The logistical complexity is staggering. In 2013, the Swiss mining conglomerate Glencore attempted to transport a large crushing machine to Las Bambas. During the journey, the vehicle carrying the equipment lost control on a cliffside section of the road. The crusher plunged off the mountainside, resulting in losses exceeding $50 million. The incident became a cautionary tale in the industry about the perils of this particular project. Then there's the environmental dimension, which may be the most complex challenge of all. The Apurimac region, where Las Bambas is located, sits within a protected watershed zone of the upper Amazon basin. The rivers that flow from these mountains eventually feed into the world's largest rainforest ecosystem. Peruvian environmental regulations for this area are extraordinarily strict. Mining operations must ensure that copper ion concentrations in wastewater remain below 0.1 milligrams per liter. To understand how demanding this standard is, consider that it's 150 times stricter than typical drinking water requirements in most countries. In 2009, a Canadian mining firm attempted to develop Las Bambas, but failed to meet these environmental standards. Their operations caused measurable ecological damage to local water sources. The Peruvian government responded by imposing a $20 million fine and forcing the company to cease all activities and exit the country. The incident demonstrated that Peru was serious about enforcing its environmental protections, regardless of the economic benefits mining might bring. Given this combination of extreme altitude, brutal weather, treacherous access routes, and stringent environmental requirements, it's not surprising that major mining corporations wanted nothing to do with Las Bambas. Industry veterans described it as the Mount Everest of mining. Technically possible, perhaps, but simply not worth the risk and expense. When China entered the picture with a $7 billion acquisition offer, the prevailing sentiment in Western mining circles was skepticism bordering on contempt. Financial analysts published reports predicting the investment would become a massive write-off. Industry publications ran stories questioning whether Chinese decision-makers understood what they were getting into. But China had compelling reasons to pursue this impossible project, reasons rooted in the fundamental realities of its economic transformation. To understand China's decision, you need to understand copper's role in the modern economy. This reddish-brown metal is far more than just a commodity. It's the lifeblood of electrification. Copper conducts electricity better than almost any other practical material. It's essential for power grids, electric motors, electronic devices, and telecommunications infrastructure. China is the world's manufacturing superpower, producing everything from smartphones to solar panels to high-speed trains. This industrial capacity requires enormous quantities of copper. In fact, China consumes roughly as much copper each year as the entire European Union combined. The scale of demand is almost incomprehensible. But here's the problem. China's domestic copper resources are inadequate. The country has identified approximately 2,250 copper deposits within its borders, containing about 99 million tons of recoverable copper. That sounds substantial until you realize that global land-based copper reserves total around 700 million tons. China occupies roughly 9.6 million square kilometers, nearly the same land area as the United States or Europe. Yet this vast territory contains less than 4% of the world's copper reserves. The geology simply didn't favor China with abundant copper deposits. This creates a dangerous vulnerability. By 2014, China was importing more than 4.5 million tons of refined copper annually. 80% of these imports came from Latin American nations, particularly Chile and Peru. China had become dependent on foreign suppliers for a resource critical to its economic security. The risks of this dependence became painfully clear in 2014, when workers at Chile's state-owned copper company launched a major strike. The disruption to supply caused copper prices in China to spike 5% in a single day. Manufacturers scrambled to secure materials, and production schedules were thrown into chaos. For Chinese policymakers, this was a wake-up call. No matter how sophisticated your manufacturing capabilities, no matter how skilled your workforce, you remain vulnerable if you don't control access to essential raw materials. Economic sovereignty requires resource security. The situation became even more urgent as China pivoted toward advanced manufacturing and clean energy technology. Consider the electric vehicle sector. China now produces more than 5 million electric cars annually, and that number is growing rapidly. Each electric vehicle requires approximately 4 times as much copper as a conventional gasoline-powered car. The motors that drive electric vehicles use copper windings. The batteries require copper for their internal connections and external terminals. The charging infrastructure depends on copper wiring. As global transportation electrifies, copper demand is projected to increase dramatically over the coming decades. Solar panels, wind turbines, grid storage systems, all of these clean energy technologies are copper-intensive. China has made massive investments in renewable energy, both domestically and through the Belt and Road Initiative. But without secure copper supplies, these investments could be constrained by material shortages. Against this backdrop, Las Bambas suddenly looked different. Yes, the mine presented extraordinary challenges. Yes, the initial investment was enormous. Yes, there were significant risks of failure, but the potential rewards were equally enormous. Las Bambas contains approximately 10 million tons of proven copper reserves, with potential for additional discoveries as exploration continues. This single mine could supply a steady stream of copper for decades, feeding directly into China's electric vehicle factories, renewable energy projects, and electronics manufacturing facilities. The Chinese government approached Las Bambas as a strategic imperative, not merely a commercial venture. State-owned banks organized a syndicated loan exceeding $7 billion, a record-breaking sum for cross-border mining investment. The message was clear. China would do whatever necessary to secure this resource. When the deal closed, Western observers predicted disaster. They assumed Chinese engineers lacked the expertise to operate in such extreme conditions. They expected cost overruns, delays, accidents, and eventual abandonment of the project. They were wrong. Engineering the impossible. When Chinese engineering teams first arrived at Las Bambas, they confronted the full force of the mountain's hostility. For 3 consecutive months, powerful sandstorms swept through the region, making it nearly impossible to establish even basic camps. Workers tried repeatedly to pitch tents, only to watch them torn apart by howling winds. The engineers worked in gas masks, conducting surveys while sand and dust stung their exposed skin. Equipment constantly jammed with grit. Satellite communications were disrupted by the weather. It was a brutal introduction to the realities of high-altitude mining in the Andes. The geological challenges proved equally daunting. The Las Bambas site sits in the foothills of the Andes Mountains, where tectonic forces have created an extraordinarily complex underground structure. Rock layers are fractured and unstable. The region experiences frequent seismic activity that can trigger landslides without warning. During one early phase of construction, a sudden rainstorm saturated the mountainside above a newly built access road. The slope gave way, sending thousands of tons of mud and rock cascading down the mountain. The road was completely destroyed. More than 30 workers were trapped on the mountain with no way to descend. For several days, helicopters had to airdrop food, water, and medical supplies to keep the stranded workers alive. It took 2 weeks to clear the debris and rebuild the route. The incident cost months of progress and tens of millions of dollars, and served as a stark reminder of the environment's unpredictability. Equipment failures compounded the difficulties. Mining machinery designed for sea-level operations malfunctioned constantly at 4,000 meters elevation. Diesel engines struggled to combust fuel efficiently in the thin air. Hydraulic systems developed leaks as seals contracted in the extreme cold. Electronic components failed due to increased cosmic radiation at high altitude. Chinese engineers realized they couldn't simply import standard equipment and expect it to work. They partnered with domestic research institutions to develop specialized machinery specifically adapted for high-altitude, high-radiation environments. This meant designing new engine management systems, upgrading hydraulic components, and hardening electronics against radiation. The main mine tunnel alone had to be reconstructed 3 times due to unexpected geological conditions. Each time workers thought they had properly secured the tunnel, seismic activity would shift the rock formations, requiring complete redesign. Each reconstruction cycle cost hundreds of millions of yuan and months of lost time. But Chinese engineers refused to give up. They approached each challenge systematically, learning from failures and adapting their methods. This persistence would ultimately make the difference between success and failure. One of the first priorities was solving the transportation nightmare. Engineers deployed surveying drones to map the mountain terrain in unprecedented detail, identifying the optimal route for a permanent access road. Then they brought in specialized excavation equipment capable of cutting through solid rock. Over the course of 2 years, Chinese construction crews carved a 4-lane, two-way transportation corridor through some of the most difficult terrain on Earth. The road includes reinforced sections in landslide-prone areas, heated segments to prevent ice accumulation, and extensive drainage systems to channel water away from the roadbed. This transportation infrastructure transformed the economics of the project. Equipment that previously required disassembly and costly helicopter transport could now be driven directly to the mine site. Supply chains became more reliable. Emergency evacuations became feasible. Worker safety was another critical focus. At extreme altitude, the human body is always operating at the edge of its capabilities. A worker who seems fine one moment can suddenly collapse from oxygen deprivation the next. Traditional safety protocols proved inadequate. Chinese engineers developed a comprehensive health monitoring system. Every worker wears a smart helmet equipped with sensors that continuously track heart rate, blood oxygen levels, and body temperature. This data feeds into a central monitoring system that can detect early signs of altitude sickness or other medical emergencies. When a worker's vitals indicate potential problems, supervisors are immediately alerted. The worker can be evacuated to lower elevation or receive medical attention before a minor issue becomes life-threatening. This technology has prevented numerous serious incidents and saved lives. Perhaps the most innovative solution was the Remote Operations Center. Recognizing that keeping large numbers of workers at extreme altitude posed inherent risks, Chinese companies invested $100 million to build a state-of-the-art control facility in Lima, Peru's capital, at sea level. Using fifth-generation wireless networks and high-definition video feeds, engineers in Lima can remotely operate excavators, monitor ore processing, and control blasting operations 4,000 kilometers away. Approximately 80% of mining activities can now be conducted from the comfort and safety of the control room. This isn't just about worker safety, it's about efficiency. Operators in Lima don't suffer from altitude sickness. They work normal 8-hour shifts without exhaustion. They can concentrate better and make fewer mistakes. Productivity has increased dramatically compared to on-site operations. In 2023, this technology proved its worth during a critical incident. Sensors detected subtle ground movements indicating an imminent landslide in an active section of the mine. The automated warning system immediately alerted all personnel. Within 10 minutes, every single worker had evacuated the danger zone. Moments later, thousands of tons of rock crashed down exactly where workers had been operating minutes before. Without the intelligent monitoring and rapid communication systems, casualties would have been inevitable. Instead, there were none. Winning hearts and minds. Technical challenges weren't the only obstacles Chinese companies faced at Las Bambas. Perhaps even more difficult was navigating the complex social and political landscape surrounding the mine. In 2021, the project faced its most serious crisis. Not from geology or weather, but from human opposition. Local communities, influenced by activist groups and skeptical media coverage, began to fear that mining operations would contaminate their water sources and damage their traditional way of life. Protests erupted. Villagers blocked access roads, preventing supplies from reaching the mine site. The Peruvian government, under pressure from environmental organizations and facing an election, ordered operations suspended pending further environmental review. For 50 days, Las Bambas sat idle. Global copper prices surged as markets worried about supply disruptions. Investors questioned whether the project would ever achieve full productivity. Some Western observers gloated, seeing the shutdown as vindication of their earlier skepticism. Chinese companies could have responded with legal action, political pressure, or attempts to force their way through. Instead, they chose a different path, one focused on dialogue, transparency, and genuine community partnership. Representatives from the mining companies initiated multiple rounds of face-to-face meetings with community leaders. They didn't just present their position, they listened. They asked questions. They sought to understand the specific concerns of local residents. What emerged was a realization that many fears were based on misinformation and the legacy of previous mining operations that had been less responsible. Chinese companies needed to prove through actions, not words, that they could operate differently. The response was comprehensive. Chinese mining firms committed to significantly increasing the financial dividends paid to local communities from mine revenues. They invested 80 million yuan to construct the Kapakmarka Bridge, a modern span that cut commuting time for surrounding villages by 4 hours. This single project dramatically improved quality of life for thousands of people. On environmental protection, the companies went beyond compliance. They imported advanced water treatment technologies that exceeded Peruvian regulatory requirements. Real-time monitoring stations were installed throughout the watershed, with data made publicly available so communities could independently verify water quality. Chinese firms funded a massive reforestation initiative covering 368 hectares, working with 34 local communities to plant native species. They released 600,000 trout fingerlings into 7 rivers in the surrounding area, actively participating in ecosystem restoration rather than merely minimizing damage. Perhaps most importantly, they created the Heart of Las Bambas Community Engagement Program. This initiative includes regular public forums where residents can voice concerns, monthly open houses where locals can tour the mining facilities, and a formal process for incorporating community feedback into operational decisions. The goal was to transform the relationship from one of extraction and resistance to one of genuine partnership. Mining companies acknowledged that they were guests in these communities and that long-term success required local support. The approach worked. Tensions gradually eased. Operations resumed. And something remarkable happened. Attitudes shifted. Today, approximately 60% of young people in towns near the mine actively seek employment there, attracted by wages that average 3 times the regional median. The mine has become one of the area's largest employers, providing not just jobs, but career development opportunities. Chinese companies offer training programs that teach valuable skills in equipment operation, maintenance, quality control, and environmental management. Many Peruvian workers have advanced to supervisory and technical positions. For the surrounding region, Las Bambas has become an economic engine. In Apurímac, where the mine is located, per capita GDP has more than tripled, rising from $1,300 in 2014 to $4,000 in 2023. Poverty rates have declined. Access to education and healthcare has improved. The mine pays more than $1.7 billion in taxes to the Peruvian government, equivalent to approximately 5% of the nation's entire annual fiscal revenue. This money funds schools, hospitals, roads, and social programs throughout the country. Chinese investment extends beyond the mine itself. They've invested $120 million to upgrade the port of Matarani, where copper concentrate is loaded onto ships. The modernization increased cargo handling efficiency by 50%, benefiting not just mining operations but all exporters using the facility. There are plans to build a copper smelting facility in Peru to process ore into semi-finished products before export. This would create additional high-skilled jobs and increase the value-added component that stays in the country. Chinese companies are also exploring the development of a solar power installation at the mine site to transition toward 100% renewable energy for operations. Additionally, China has supported the renovation of the Belgrano Freight Railway with a $200 million investment. The first phase now operates at full capacity, moving 2.65 million tons of cargo annually while reducing transportation costs by 80%. The results: a strategic victory. A decade after China's controversial $7 billion investment, the financial results speak for themselves. At current copper prices of approximately $10,000 per ton, the 2.7 million tons of copper already extracted from Las Bambas have generated $27 billion in value, nearly 4 times the initial investment. But the mine still contains more than 10 million tons of recoverable copper reserves. At current prices, this represents nearly $100 billion in future value. The project that critics called a money pit has become one of the most profitable mining investments of the century. The strategic value extends far beyond financial returns. Every year, approximately 400,000 tons of copper concentrate depart from Peru's Matarani port aboard specialized cargo vessels. 23 days later, these ships arrive at Nanjing port on China's eastern coast. From there, the copper moves directly to major Chinese smelters like Jiangxi Copper and Tongling non-ferrous metals.